Second problem, no calculator. I already sketched the two functions. We want to find the area enclosed by the two functions. So we're talking about the area in between. Intersection points are where radical x equals x squared. Solve that by squaring both sides. You get x equals x to the fourth, and then bring the x over. So when you factor out an x, you get x to the third minus 1. So our intersection points happen at 1 and 0, which you can tell. You can also, they're easy functions like that you can tell. So you know that your integrals, as long as we're going on the x direction, are always going to go from 0 to 1. So the area are all of the little slivers from 0 to 1 of radical x minus x squared. Practice integrating by hand. There is no calculator here. This is x to the 1/2, so we have 3/2 x to the 3/2, sorry, 2/3 x to the 3/2 minus x to the third over 3 from 1 to 0. Pretty straightforward. 2/3 minus 1/3, that's going to be 0. 2/3 minus 1/3 is 1/3. So again, our area here was 1/3. Find the volume of the area enclosed when rotated around the line y equals -2. I'm going to keep using my same picture, only I'm going to draw in line y equals -2 with right here. So this time we're rotating down to that axis. So it's going to have a hole in it. It's not going to be a cylindrical hole, so I need to write an expression for the outside radius, which is the big radius squared, and the little radius squared. So remember that the distance to the x-axis is the function. So the distance from here to here is radical x, plus I go 2 more. So this is radical x plus 2 squared. Little would be x squared. That takes you to the x-axis, that's this distance. So I got to go 2 more there. Integral 0 to 1, because we're still rotating this way. So we're going bounds on the x-axis. These are both circles, pi r squared, add up all the slices, that's what you get. If you're going to integrate this, you have to expand first. So expanding, you get x plus 4 radical x plus 4. And then here you have x to the 4th plus 4x squared plus 4. And you'll notice here that the 4's are going to go away. And then you just have the leftover amounts to integrate. So 0 to 1, x plus 4x to the 1/2 minus x to the 4th minus 4x squared dx. Integrate. You can practice it. You get all you're going to get is the fractions, because the 0 and 1 are going to cancel all the variables out. So we have 1/2 x squared plus 8/3 x to the 3/2 minus 1/5 x to the 5th minus 4/3 x to the 3rd. So basically these are all 1, so we're really just adding the fractions, subtracting the fractions. I'm going to let you finish that part. You can do that arithmetic. I want to make sure I get the video in the right time. Find the volume of the area enclosed if cross sections of semicircles are inscribed perpendicular to the x-axis. So in other words, we have our same area, only we have semicircles coming off the page. So you got a bunch of little circles there. That's not a very good drawing, but if you make semicircles following that pattern, you're like, okay, I'm looking at they're perpendicular to the x-axis. Okay, so formula for a semicircle, I need to know the formula for a side, which happens to be the radius, or which happens to be half of the radius. Okay, so the radius is half of that distance, so the side is the top minus the bottom. So one quote side that we use in all our formulas is the square root of x minus x squared, top function minus bottom function. Well, our radius, that's a side. Our radius of a semicircle is half of that side. So I'm taking the integral from 0 to 1 of, it would be pi r squared if it was circles. It's half a circle, so it's half pi r squared. But my r then is half of the side. So it's radical x minus x squared. And if you remember, when we simplified before, that's where the 1/8 came from. So when you expand this whole thing, you really have a pi and an 8, and that's 4, so 4 times 1/2 is 8. You can take the pi over 8 out front. So you're going from 0 to 1, pi over 8 of radical x minus x squared squared. And again, I think we've done enough of these now, you can expand this and check it. Okay? So semicircles, if this would have said squares, you would use this side square. We always want to find what is one side, and then we can go and use that in our formula.